Good. So we're recording. So look, thanks very much for joining me today for the second part of the lecture. So my name is Frank Walsh. I don't know whether any of you have taken modules with me before. So what's going to happen now is for the next couple of weeks, I'm going to take you for this slot to cover essentially client side and React in particular, okay, to develop React apps. So that's what we're going to look at over the next couple of weeks. So this will complement what you've done with Dermot already, right? Dermot has done some great stuff with you there in terms of the back end and what's possible there with lambdas and such. So we're going to continue that journey using kind of JavaScript or full stack JavaScript. I will keep going with TypeScript because that's what you're using already. And we'll start from there. So let me just kick off my presentation here and share my screen. And by the way, as we go along, if anything happens in terms of quality, whether it be sound or you want to ask a question or anything like that, please don't hesitate to let me know or to contact me through here. I don't mind being interrupted. Okay. All right. So let me just start off this slideshow. That's good. That's a good start. And let me just share my screen. Right, so hopefully you're seeing my screen there. Is that okay? You should be seeing React. Yep, cool, brilliant. All right, so that's what we're going to look at, React. It's for developing web and native user interfaces. So I'm going to introduce it today. The plan is today, we'll see how far we get. Anything I don't cover today, I'll probably record it during the week so that you'll have it. So I'm going to give you a little background about React, talk about the V and MVC, Model View Controller, and that's where we exist with React. I want to talk about TypeScript extension syntax, and also I want to introduce the developer tools that you're going to use for this portion of the module. Then I want to get into React components and React component basics, and finally finish off with material design in terms of user interface styling. So I don't know whether we'll make it to material today, but sure, look, we'll give it a go. In terms of the website, by the way, let me just here we go. Right, so hopefully you're seeing the Enterprise Web Dev website there on your screen. This is where we're at. We've just moved on to this topic, Introduction to React. We're going to go through these slide decks now. I've also put up two starter labs, one to introduce the basic concepts of React and also to use something called Storybook. And also, I've also put up a lab about Vite, right, to introduce the Vite tool, which we're going to use to help us develop React apps, essentially. I've also put some startup code there. So just to let you know, that's where we're at, and that's what's up there. Hopefully you can see that okay. Right. So back to the slide deck there, and let's move on. Let's talk a little bit about React. So React came from Facebook, which is which is now Meta, right? It's a JavaScript framework for building dynamic web user interfaces, okay? Single page apps or SPAs, right? It's reasonably mature. It's been open source since 2012, so it's been around for a while. And it's termed a client-side framework, but really, to be honest with you, it's more like a library, JavaScript library than a framework. Why, you might be wondering why we're actually doing React. Well, the reason why is that it's immensely popular web framework to use. You can see some of the stats here that I'm just putting up here. React is up at 40.58% there as the most used frameworks among developers worldwide last year. It's right up there with Node, right? Which you're familiar with too. So you can see in the module, we're kind of giving you the best of breed of technologies, hopefully, and good knowledge of that. I also asked ChatGPT what's the most popular framework in the industry, web framework in web app dev, and it came back with React too. So that's why we're doing React. Before React came about, the kind of predominant, I suppose, in the industry, the predominant approach would have been MVC, Model View Controller, right? That was the convention promoted by most of the market leaders out there. So some of these products are still around, by the way, and are still quite useful. Things like Angular, JS, Ember, Backbone. These would have been examples of those frameworks. So React kind of broke from that MVC approach, that paradigm. It's not MVC, it's just V. It's just Vue. It just deals with the user interface, right? And it kind of challenged the established practice of kind of separation of concerns that we used to have with Model View Controller when developing web apps. So I'll not get into that too much, but just to kind of give you an idea. And a lot of these frameworks back then would have used something called templating up at the view to create user interfaces. Things like handlebars. Angular had its own built-in syntax for allowing easily defined interactive user interfaces. But they were widespread in the V layer back to then. But React is based on essentially what they call components, and that's their philosophy, right? So the philosophy of React is we build components, not templates, okay? And it's all about the user interface, right? It's not focused on the business logic, or it doesn't focus on the data model, right? The M or the C, right? It's focused predominantly on the V, the user interface. So you might be wondering, what is a component? Well, it's a unit comprised of two things, right? A description and a behavior for a user interface. The description will be specified in HTML, and the behavior is described in JavaScript. And these are tightly coupled together, and they're co-located together in a component, right? Pre-React, the approach would have been to decouple these things, right? To separate your template, your user interface description from your behavior. But we tightly couple those in React components. And the benefits are improved composition. You're composing both together into one unit. And that gives us greater usability as well, right? So we can reuse components in other applications. Now, it doesn't mean you can't have business logic in React components. As you will see as we go through the module, there's features there that we can allow us to bring in what you would call business logic and models in there, things like contexts, things like state, different ways we can manage state and fetch and handle data. But we'll come to that as we go along, okay? But for now, let's just focus on components. So let's just jump straight in and say, how do we create a user interface description? How do we create a web application user interface using React, vanilla React, okay? So we can use the React library. We can create a web page that imports the React library into it, the JavaScript library, and we can use, in that React library, you can use the create element function to create a HTML element. And we use the create root function of the React DOM library that we can import as well, that we can bring into our web pages, which we can use to select the existing document object model node that we want to attach a particular element to, right? In a web page, right? So your document object model is the programmatic representation of your web page. So when we use create element, there's different arguments we can use in this function. We specify what type of element we want to create. Like, is it a div? Is it a button? Is it, a header? Things like that, right? Also the properties, things like style, any event handlers that we might want to have with this element. And also we can specify children. We can specify no children at all, or many different children elements in the element that we are creating, okay? To be honest with you, as you'll see, we don't really use create element directly, right? Too cumbersome to do that. We're going to create our React components in a declarative way, as you'll see in a minute, right? But nonetheless, it's good to know essentially what's going on under the bonnet in terms of the code, the JavaScript code that gets generated at the end of the day, right? In terms of the DOM and the React DOM library, we can use that. What arguments we use that? So we can specify what we specify when we call create root is the DOM node, right? The document object node that we want to mount our new element onto in a web page, right? So it might be a div, it might be something element in that we want to mount our new element onto or render into. Think of it that way. So you'll see this in the code. I'm going to go through some code examples in a minute that can kind of illustrate this kind of thing. So what I've got, and this is up on the web page I just showed you there. If I jump back in here, you'll see this startup archive here, which I have some user interface description samples in, right? So what you're going to see right now is in here, right? So I've got some, this is in the lecture archive, the code demos that we'll be kind of looking at now to talk about React in terms of how it works, okay? And you can download that now if you wish while I'm talking to you and go through the code yourself while we're chatting away here. But that's that, just to let you know, that's kind of where I'm getting some of the examples that we're going to talk about now. So look, you guys have been doing TypeScript, I know in the first part of this module. So we have the opportunity to kind of retain that and kind of go, I suppose, full stack with TypeScript and also use it with React, okay? It works well with React. We can use TypeScript and we get all the advantages of TypeScript in React as you would have doing work on the back end in terms of developing APIs and developing lambdas and things like that, in terms of adding type definitions to JavaScript code bases. So we got type safety. TypeScript supports what we call JavaScript XML, right? Or JavaScript markup language, that's what we use in developing React apps as well, right? We call it TypeScript XML. So it integrates seamlessly with React, so we can interact. We can, you know, TypeScript kind of interacts nicely with JavaScript XML, which I'll talk about in a minute. And we can include it in React using these libraries here, types React and React DOM. So you'll see this in the lab, right? So we're using it. It gives a better developer experience, I feel, right? But the thing about it is TypeScript, and you probably had this in the first part of the semester as well, TypeScript is not JavaScript, right? So it's not going to run in a browser. And our client applications here, our client web apps here, what we're developing here needs to run in a browser. So it has to be transpiled, right? So we need a mechanism by which we can transpile our JavaScript, our TypeScript, excuse me, into JavaScript. And again, we'll talk about that in a sec, right? So let's see how we can define a user interface description, implement one, should I say, using React, right? So what I'm going to do here, it allows me to jump into, and we're going to do this what I call the imperative way. I'm going to drag in some examples here. So this code that you're looking at here, this is what you have when you, if you look at the examples that I put up on the website there, the archive that's there. And let's have a look at the first example here. So here we have a HTML document. Now, I'm assuming, folks, that you have a bit of knowledge of HTML. Okay, and you know how HTML, a basic web page works, okay? So if you look at this HTML page, you can see here, there's my HTML elements, and you can see in here, in the body, I've defined this div, look, mount point. So this div element here has an ID of mount point. You can see here now, look, I am bringing in my React script and my React DOM script, right? So I'm bringing those into my web page here. And then I'm defining a script down here. And look, I'm using that create element. So I'm actually implementing a user interface here programmatically using create element. So I create a header element here. You can see that, look, H1. So that's the, you know, the HTML type, the element that I'm creating here. I'm giving it a bit of styling, class name heading. So that's CSS, class name instead of class. That's just the way we do it with React. And then I'm just giving it a value of languages. And then I'm creating, see this, item 1 and item 2 and item 3, and then I'm creating 3 different elements. These are list items, right? So there's no kind of styling here or anything I'm specifying here, but I'm just giving them one value: JavaScript, Java, and Python. And then here I'm creating a list, and I'm using create element. I'm creating an unordered list. You see that there? And then I'm adding in item 1, item 2, and item 3, right? That I've created here, right? So my list items into an unordered list. And then finally, you can see here, I'm creating a div, right? I'm creating a div element. You can get a bit of style here, class name pad, and then I'm putting in my div. Look, as I said to you before, with a create element, I can specify 0 to many elements inside an existing element. So I'm putting in the header and I'm putting in the list. And finally down here, I'm defining my root element. React DOM, I use the React DOM create root. So again, remember I said this, I use this to specify which node in the DOM, the document object model, the programmatic model of this web page, which node of the DOM I'm going to render my React element into, right? This root element. And it's mount, look, get element by ID mount point. There it is, look, see, right? And then finally, I call render, root element.render, and I pass in my root element. So look, let's see how this looks. If I open this with live server, so this is using the live server plugin that you have with VS Code. So it allows me just to view that web pages quite easily, right? I'll just open it in the browser, and there we have, look. There's our first React user interface, right? I've defined all of that programmatically using the React library, and I've done it in an imperative way, right? It's not the best way, but it works, right? JavaScript, Java, and Python, right? Similarly, if I go back here, look, there's another example here. This is exactly the same thing, right? But it just shows you again, it renders the same web page. It's just done, the programming is a bit different. This way I am nesting React create element calls within an element. So you see here, I create the root element first, and then inside I put the heading. Inside I create, which is a div, and then I put in again my unordered list, and embedded in the unordered list are my list items. Okay, essentially the same way of doing previous one, but just this time I'm just nesting my create element calls, function calls. Okay, and again, look, just to view this, you'll see looks exactly the same, right? Both look exactly the same. They do the same thing. So that's our first 2 UI descriptions, right? And that's done imperatively, right? And imperative programming, you do everything kind of step by step. You describe exactly how the program operates, right? And it uses statements that change the program's state. And I'm using create element there. But as I said in the previous slide, we don't actually, in practice use create element directly. Okay, there's another way we can do this, and we can take it a declarative programming style. And this expresses logic without describing the controller flow, and we can focus on what the results should be without specifying how we can achieve these results. So that's kind of where we want to move. And to do that, we want to use the declarative way to do user interface descriptions. That's where TypeScript XML comes into, which seamlessly kind of integrates with JavaScript XML in React, right? So this way we can get the full power of TypeScript and also combine it and kind of embed in HTML into it as well, right? So we can get that tight coupling that we want in components between behavior and description. We can describe our component essentially in XML, in HTML, using our elements, but also we can embed in their TypeScript to give it that dynamic quality that we need, right? The problem with this is, like I said before, is that we've got to transpile it before we send it to the browser. Let me show you what I mean. I have an example here. Here's another web page, tsxerror.html. So let's have a look at this. So what I'm doing here, look, is I've got the same web page again. It's pretty much the same. I'm defining my mount point. I'm importing my React and my React DOM libraries here, my scripts, right? And in the script, the script I've embedded in here, look at the way I'm defining my root element now. I'm actually defining it in a declarative way. I said, this is what I want in here. I want a div, right, with the class name attribute pad. I have my heading here. Then I have my unordered list that contains 3 list items, right? And I've just dumped the HTML into the JavaScript, right? And I'm assigning it to this root element, okay? And surrounded it by brackets, by the way. It's kind of important. All right. If I try and have a look at this, the live server, it doesn't look like that. That's what it's supposed to look like. It's not looking like that at all. And if I have a quick look, if I just inspect this, right, and have a look at the console, you can see here, uncut syntax header, unexpected token, and I got this chevron thing. I go back to the code. This isn't JavaScript, right? And if it's not JavaScript, it's not going to fly in a browser, right? So we've got to take this code that's contained in this script, and we've got to transpile it from this, which is TSX, right? Or JSX, should I say? And then we got to transpile that into JavaScript. So that's something we have to do. How do we do that? Well, we can do that using a transpiler, right? So a transpiler will allow us to do that, right? One of the most popular ones out there is Babel. I think I have it open here in the browser. I do. So here is Babel, and I can use Babel. I can try out Babel. I can automate this process, and that's what's going to happen actually when we move into Vite, that we won't have to do this manually, because that would be really painful. But what we can do here is we can take our kind of JSX, right? JavaScript XML. And then what we can do is we can put it in here. We kind of define it what it is, do some settings here. I'll not go through these settings. There's no kind of need, but I do specify it's React, it's TypeScript, it's stage 0. We'll kind of use the kind of stable version of this. And we can kind of make it look nice here with some of these settings. So Babel takes this and then transpiles it to this, right? And if I take this code, right, I can go back here, I'm going to JavaScript here. There's my TSX, there's my Java TypeScript object notation, or TypeScript XML. And if that's what I dumped into Babel, and there's the output, right? And then what I can do is I can take that output, and let's have a look at script 4 here, or web page 4, 04 tsx.html. See here, I'm porting my JSX post transpile script here, right? This is proper JavaScript this time. It's going to run. Yeah, I'm importing it here. I'm kind of taking it in here, referencing my script file here externally. And then if I open this in the live server, happy days. I've got my React application working again, right? After transpiling. So transpiling is important if we're using TypeScript, and if we're using TSX, more importantly, TypeScript's XML, we've got to transpile it before we actually run the app in browser, okay? Otherwise, it's not going to work, right? So that's happening all the time when you're using React with TypeScript, okay? So it's worth noting that. So to go back, there, you'll see that if you have a look at these examples on your own, it might be good to go through them, and just kind of gives you a better understanding of what the React library is doing, and how the React DOM works, and the difference between the imperative style and the declarative style. We can use the declarative style to make the development of our components, our React components, easier. But we've got to transpile them then into JavaScript to get them to work with the web page, right? And you can see and if you actually have a look at that, just take a look at that slide there. You see what it transpiles into. And if you look at the previous examples, the imperative programming examples I've just looked at, that's what it transpiles this into. If you have a look, he's using the create element function on the React library here to create these elements, and the React DOM.create root at the bottom here. So it's pretty much the same, apart from these. The formatting is a bit different, and these comments put in here. It's a bit verbose, but nonetheless, it's more or less the same as what we've seen before. So transpiling is important. Okay. Let's talk a little bit about TypeScript XML, right? It's HTML type markup. It's actually XML code. There's some minor HTML tag attributes that need to change in there that don't clash with kind of reserved words in TypeScript and JavaScript. So things like for defining style and CSS classes, for CSS classes, we use class name, the class name attributes to the class. And if in labels, if we're using for to indicate what input element a label is for, we use HTML4 instead of for. So it's kind of worth noting that as well. You'll see that, right? So using TSX, right, we can code in a declarative style, and we can kind of put our user interface description in as it should be, as we would want it to appear in a browser, right? And we can inline it with TypeScript. We can embed TypeScript into it, right? So essentially what we're doing is combining templating with TypeScript, right? All in one kind of go, all in one kind of unit here to create a component, a React component. So that's kind of where we're going with this. So transpiling TSX, I kind of said this already. Browsers don't do TypeScript. Needs to be transpiled into JavaScript. And what can we use to transpile? Well, you just saw Babel there. I can use the Babel platform or Babel libraries to do that for me. You might have been doing that with Dermot already. I don't know. But what we will actually use here, and what I'm going to be talking about pretty soon, is something called Vite, right? And how can we do that? We can use manually via the REPL or command line if you're using Babel. Or what we're going to do here, how we're going to do it to make development easy for us guys, is we're going to use an instrumented web server. So we call it Vite, right? We're going to use Vite library instrumentation. So what we'll be able to do is develop our components, and Vite will work away in the background, and it will automatically transpile them as we're developing them. So we don't have to kind of go toing and froing. Yeah. So that's kind of where we're going. So this is brilliant for development because we can kind of do it on the fly, right? And then when we're happy with our components, we can use bundler tools as part of the build process. And again, Vite allows us then to do a build of our app, right? When we're happy with it and we want to maybe, release it. Okay. So that's transpiling, and that's a quick introduction to kind of where we're going with this and the difference between TSX and just regular TypeScript XML. That's what we're going to be using. So you get experience of that in the lab. So what we're going to be doing here is we're going to be developing components, right? And what a React component is, it's going to be a TypeScript function that returns a user interface description. So that's what a TSX is, right? And we'll be able to reference these components in our applications. We'll be able to reference these components like a HTML tag. So for instance, like I might develop a component called dynamic languages. And then, to actually put this component into our web application or web page, then we can, again, we use create root on the React DOM library. We specify a mount point in a web page, and then we can just render our React component into that on that mount point there, exactly where it is. A bit like what we just saw in the examples there, right? So let me just show you a quick example of that. We'll jump in. You can see a simple component here, right? So I have my mount point here, right? And you've got simple component transpile. You can see my mount point, and I'm importing React DOM, and I've got my simple component up here. Let's have a look at that. So we see it's in the JavaScript folder. Let's have a look. There's my simple component source. So you can see dynamic languages. So I'm specifying, again, it's the same page. So it's the same thing we've done before. This time we're specifying it has a proper component, React component. So I'm defining a component called React languages. It's a function, right? It's a function that returns TSX. You can see it here, like so. See div right? And I'm specifying my web page as I want, or my HTML as I want it here. Nothing dynamic about it really so far. And then you can see here, look, down the bottom, root, React DOM, create root, document, get out by ID, mount point, and then root.render. And look, see how I specify it in a HTML style, right? Dynamic languages, right? And I will render into the root element. Okay, so that's it. That's no good to a browser. That would need to be transpiled into that, right? So again, if I throw that at Babel, right, and get it to transpile it, it will generate that for me. And then that's referenced by my simple component here, okay? So hopefully that makes sense. So there's your first simple, the basic React component, right? And this is a TSX file. See, it's TypeScript XML. There's your XML part, your HTML embedded in there. Now we haven't done anything. We'll get a bit more kind of interesting with that now as we move along. Okay, so cool. Any questions so far? Are we all okay with that? I think it's vital, and the labs that I'll be putting up, you know, again, and I think will be probably the same with Dermot's stuff. It is very important. It's okay for me talking about it here, and maybe you can use the lectures to kind of get an idea of how things work. But definitely doing the labs and working your way through the labs, that will give you a better understanding. And the examples that I'm doing here of how this all works. So look, that kind of introduces a little bit about React and TypeScript XML and creating React components. We'll come back to React components in a minute. But what I want to talk about now is the developer tools we're going to use in this module. So the first one I want to talk about is Vite, right? So this is the web page for it. It's a next generation front end tooling, right? So it allows us, has some nice features in it. It's got scaffolding and a generator, so essentially scaffolds a web app for us. In our case, a React app, right? A React single page app. It's got a development web server built into it, so it'll do talking about transpiling there. So when we're developing our React components, it's going to automatically transpile them for them. And not only that, it's going to do it every time we change a file. And then we're going to get live reloading as well. So if we open the React app in a browser, like I was just doing there with the live server, it'll do a kind of a live reload. It's called HMR, hot module replacement. So I just make one change, and as soon as that file is saved, Vite will see that update happening. It will do a full transpile again, and it'll render the whole app, our React app in the browser again, right? So that's pretty handy when you're doing development, right? You don't have to be stopping and starting servers all the time, which is really painful and costs a lot of time. Also, it's got a builder built in, so we can build production standard versions of the app. We can do things like minification, bundling, all that kind of stuff at the end when we're kind of happy with our React app and we want to actually release it into production, okay? So you will see in the lab how you do that, right? The second tool I want to introduce is Storybook. So React is all about developing components, right? And Storybook is a development environment for React components. So it allows you, it can get, you know, developing React components can get a little bit complicated, and particularly when you're combining different components together to create a full app. Then sometimes it's nice to be able to develop your React apps and test them in isolation. So that's what Storybook gives you, right? Allows you to develop your components, your React components in isolation. And that way it promotes more reusable and testable components, right? And also quicker development. So I can ignore app-specific dependencies and just develop a React app in isolation. So it's got a very good website on it. You can go in there and kind of have a look at it. But what I'm going to do is, it's probably a good place to start having a look at Storybook and how it works. So just a little bit about it. To install it, it's easy enough. You just do an npm install for Storybook. Again, if you go to the website, it'll give you details about that. And once you have Storybook installed, it has two aspects to it that allow you to test your React components. It has a web server, and your web server, just like Vite and that transpiling I was talking about there, It will do that live transpilation and live reloading all the time, right? So I can just start as a kind of a line in a web server. I can start up Storybook. It will listen on a port. It will start up that web server, and it'll give you also a nice, excuse me, web browser user interface to allow me to actually look at all the different components and stories that I've created for those components. I'm going to talk about what stories are in a minute. So to talk about the Storybook user interface, how it looks, it's got probably it's best to go up and actually open this up and show you it here. So again, I'm kind of jumping ahead here, but if you have a look online, again, when you do the lab this week, right, you will be asked to download a starter, some starter files, right? A starter project. And in that starter project, what I've put in there is some sample components that you can use, right? To have a look at very much that static component. This is kind of stuff that I've referenced inside in the slides there as well. And also I have stories in there too, right? So these are our stories too. And if I run this, if I run Storybook, what I can do is in my browser, if I open my browser here, if I go into Storybook, you can see here, these are all my components, right? So I know there's a lot here because, you know, this is the lab. But what you'll see in here, I've put a bunch of samples in here. So if you follow the instructions in the lab, you'll be able to have a look at these samples. And these are all, see, these are components, static component, TSX embedded variable. So these are different examples of React components. And what you can do is you can have a look at them. And these are different stories associated with them, right? And you can see up the top here, we've got a few different ones. There's some example ones there for buttons and stuff that's built into Storybook. That won't be in. Anyway, to go back to the slides, what you're actually looking at there is, this is the component catalog, right? So in here, down here, I have a list of all the different components that I have stories about. These are all the components that I've developed, right? If I select the component and a story, it'll open up the different stories associated with that component. And then once I do that, in here, it's going to show me how it will render, how it will actually look in an app, right? So you can see here my dynamic languages, Erlang enclosure, right? So you can see there, that's how this will look. Similarly, if I select this component here, this is how this component will look. This is how this component will look, right? And you can see here, and it's a good way to test them, right? Down the bottom here, I have controls. So these are the component arguments. This is the kind of data I'm passing to a component. You can see for the basic components here, there's nothing here, but down further here, I have different controls. For instance, languages, right? So this is the name, different controls and heading, right? So ranked languages. And what I can do is I can change these. These are the kind of properties that I'm passing into a component. What I can do is change them and see how my component will react to this. Like, so I can put in, you know, best languages. If I put in best, you can see here dynamically it changes. So that's just a quick kind of example of story. So there you can see here, you've got your components, you've got your component rendering, and then you've got component arguments and actions, right? Actions are callbacks. They can kind of be used, that can be used to kind of click on and see when you click on a button or different controls on your React component, how they kind of, it records the actions that happen. So it gives you a graphical user interface to interact with components, arguments dynamically without needing to code it. I can do it dynamically here in the browser here and test my components. And that's kind of handy. It's very handy. And these are stories, by the way. I can create stories. So each component, I can create one or many stories. And that's where the kind of name Storybook comes from. Okay. So a story is just to talk about it. What is a story? A component may have several states, and each state affects how it renders. So each state is termed a story. So for instance, remember the dynamic languages component we were looking at, that list of languages. I might decide, right? The states might be that the default kind of state for that component is it's going to be displaying 5 languages or less, right? So in that case, we want to see it render the full list. We can also put in a boundary state, and the one boundary state might be an empty list. What if no languages are there, right? What if there's no languages, right? So I should render a no languages message ideally if there's no languages, right? That's what I should see on the component. And then we might have an exceptional state, and the exceptional state might be more than 5 languages. So I render the first 5 and I see more button link, I see more link to display the next 5, right? These stories, consider they're design considerations, and they're written in the component story format. I'll show you that now in a minute. A CSF, and these are they're functions that describe how to render components, right? So we'll have a look at that in a sec. But like just to give you an idea, so a list of component states or stories. So see dynamic languages. I think I have the example here actually in our browser. I think there might be an in class. Yeah, so there's dynamic languages. So you can see the basic state, and then you see exceptional state. If I click on that, look, you can see here in my controls, right, in languages, I have 9 here, and I have, look, my see more button appears like it should. In the basic state, I just have 4, that's all fine. And in my boundary, it displays nothing. Well, it actually should display no languages to display, but I didn't code it that far. I didn't put that code in, but I should. But there you go. That's how I can test my components, right? That's kind of handy, right? So we can also define component groups, right? When a component catalog is large, right? So this helps. So you can see group A and group B. I can separate out components. So again, you know, as you will see, as we develop more and more components as we go along, you'll have quite a big component catalog. They'll usually be categorized, maybe on different pages or on different parts of the application. So we can use that to separate. We can separate it out easily enough by using the separate a slash in the name, right? But I'll come to that how it's how we do that in a minute. So look, I want to talk about how we define these stories in code, right? So story files end with the file extension is .stories.ts, right? That's the convention, okay? And when you run Storybook, it will look for files with these extensions, right? And to create your catalog of components and stories. And you can have 1 story file per component. You can't have 2. So you can have, each component has a story file. And in that story file, you can have many different states, i.e. stories. So to have a look at the code, just to digest a bit of the code here. Now, I know it looks a little bit complicated, but really there's 2 main features or 2 main elements of this. One is the default export, and this is the default export of metadata. You can see it here. So I'm defining this constant meta, and you can see here it has a title and a component. So in this case, it's dynamic languages. So this is the component. Look, this is the component I'm going to be writing stories about. This is the component that this story file is about, dynamic languages, right? Title and component. This is kind of boilerplate type stuff. So you'll see in every single story, it'll have this form, right? It'll have this structure. And it satisfies meta here, right? Meta, which is type of dynamic languages. So this type annotation specifies that meta should conform to the meta type. This constant meta conforms to this meta type. This meta is a generic type. I know you've done a bit of TypeScript, right? It can operate with different types of inputs. And in this case, the input will be type of dynamic languages. So we export this meta, right? We export default meta, right? That's the default export, the metadata. And think of this as the metadata and how Storybook lists the components. That's the title, and that's the component it's dealing with, right? Then down below further, we define a story, right? So a story is implemented. So a story is implemented as a function. You can see down here. So I'm defining some data I'm going to use in my stories here. Different list, an empty list, and an exceptional list, right? For this example here. So just defining the data that's going to be used in the story. To control the component, and then I can define different stories. So here I'm defining, look, export constant basic. So the basic, which is a story, see the story, which is a story object. of the same type of meta as meta, which is dynamic language, right? And then you can pass and see the arguments, right? So you can see here, these are named exports, upper camel case usually in terms of how we specify them. And there's 3 stories in this component. There's a basic story where we just pass in the languages list and a heading. Then I have a boundary and exception. See it here in the code, guys. Open it up here and have a look at my stories. Here's the in-class example. So you can see it here actually in the code, right? So my basic type story, and then this args function is important. The args function essentially specifies the properties or the arguments I'm passing into this component for it to work, right? So list and dynamic. You can see up here, by the way, in components, I have sample components, and here's my in-class example. And you can see in my in-class example, I'll be talking about components in a minute, but I've defined the interface for the properties of this component. It takes a heading and it takes an array of strings as well. So it takes a heading, which is a string, and it takes languages, which is an array of strings. So you can see here, my demo here, it's a demo components. That's the name of my component. It's a demo in this case. It's a React functional component, right? So I use this to kind of specify it's a functional component and properties. But look, I'll talk about that a little bit more about that in a second. But that's writing stories. You might have seen this. I don't know if you've kind of come across the satisfies operator yet in TypeScript. You might be wondering what it is. It's kind of new, just in case you haven't. It came in with TypeScript 4.9. So it just allows you to check that an expression matches a particular type. So look, it's used in stories to ensure an object conforms to a type without casting, right? So I don't have to cast it. So to give you an example here, if I define an interface person, so a person has a name, which is a string, and an age, which is a number. And I can say let person is equal to, right? Alice, person, this object here is a name property, which is Alice, age 30, occupation developer. And I can say satisfies person. So it will just check, right? That person has a name and an age property that is a string and a number. You get me? Okay, so that's kind of what's going on there, just in case you haven't seen it before. I can group stories, like I said before, using the path symbol or the slash, right, to indicate a component grouping. So groups and subgroups. So you might have saw it there. If you look in the example that I have here, a lot of the examples in the stories here, you can see here the name is sample/01 static component. If you look how that renders, right, into the you see sample there, so sample/static component. You see that? So it's a grouping mechanism, right? It's a way we can group different stories together, right? So that's kind of how that would appear in language. So here would be languages/dynamic languages. How that then, when we start up the Storybook web server and have a look at our components and the stories, under languages, we will have dynamic languages. Right, and then I could have languages/static languages, and I would have another one in there if I decide to do that there. You can see in exercises, we've got 4 different component stories here. Right. So that's Storybook. I just wanted to introduce that. Let's go back to components. I won't keep you too much longer, guys. Let's just go through a little bit about components. So just to let you know, the code that we were just looking at there, that's the starter project for the lab this week, okay? And if you have a look in there, the structure of it, it's called Basic React Lab.ts, right? And it's got a configuration built into it there so that you can just do an npm install and install everything you need, including Storybook, to get this to work, right? And then when you open it up in VS Code or VS Code, hopefully you're using that, then you'll see inside in the source folder, you'll have components. And in components, you'll have exercises. This is where you'll do your lab exercises, and you'll see some empty files in there that with a to-do in it. And that's where you kind of get to learn about developing components. You'll also have a samples folder there, which has a bunch of sample components that you can use to reference to see how you build these components. The stories, then you'll see in source there's a separate stories folder. And in there, like again, you'll have an exercises folder where you'll practice creating stories yourself. And then you'll have a samples folder as well, where I have a bunch of sample users storybook files in there as well, which you can use to kind of see different features. So as you can see in there, if I just jump into the code there just to show you, in the samples and stories, you can see here there's different component stories. So they do kind of different thing, and they use all the different all these stories use the sample components that are up here. And the sample components have different features in it that you can that we can talk about, that we're actually going to talk about now. Okay. So that's the demo samples. So see the lab exercise for these demo samples, and they will hopefully help you. So up to now, the TSX component that we had there, all it really did is it was fairly static, right? And you know, I talked about this tight coupling of TypeScript with your HTML and user description. So let's see how you would do that. So this is another React component here, okay, guys? And if I have a look at it here, I'm defining it. Demo is a React functional component. So I'm defining a functional component here, right? So the constant, that's demo, that's the name of our component, right? It's conventional to start it with a capital letter, right? And that's what we're doing here, right? So we're typing demo as a react.fc, react.fc. This is coming from the React library. It's a functional component, right? We're telling TypeScript that demo is a functional component, right? And it is a function, right? So we have our brackets here. We're not passing any properties in here yet. We will be. And then we're just defining some constants here. So array of strings here, which is a list of languages, and these are modern languages. And then you can see here, look at what I'm returning here. So this is our TSX in action here. I've got my HTML, and then look in here. I'm using the curly braces, right, to reference a variable embedded in the TypeScript XML, right? So I can embed variables in our TypeScript XML. You can see it there, $ header. You see it there? And then also, look, you see here, sorry, that's just a regular JavaScript, but you can see here, look, so I'm doing a map here, right? So I'm mapping the languages array onto an array of list items. You see that there, right? So that's it in action, right? So it's pretty cool, right? And then down the bottom here, I just default export default demo, our React functional component. So hopefully that makes sense. Again, this is in the example, so you can run this in your browser, or run this on your host at home, and you can mess around with some of these values and see what happens, right? And also there's stories written about it, so you can use the sample story associated with this embedded variables TypeScript, embedded variables components, should I say, and you can use it to test it, right? Reusability. So up to now, like you might be thinking, sure, what's the use in that? Like, and how could I reuse that? Like I've kind of hard coded in my variables here. That's not much use. So we can introduce some parameterization to our components, and we do that through properties, or props for short, right? Component properties and attributes and parameters. So we can pass properties to a component, given each property can have a property name and give it a value to it, right? And then this is when we're kind of creating a component or passing it in into a web page, right? And would be transpiled into such. But inside a component, we can access it via the props object. So we can define a props argument here for our functional component, our React functional component. And then I can say, look, if I'm saying prop1.name is equal to some value, I can just do props.prop1 name, and I can get at that value inside our functional component. Properties are immutable, right? And it's part of the components design, React functional component design. To give you an example, let's have a look at our samples again, right? Here we go. Yep. So you can see here props, right? React functional component, right? It accepts, so there's my, I'm defining, by the way, interface, right? So I'm defining my interface. So it shows me the shape of what language is going to be. So it's going to have a heading, a string heading, and an array of strings as languages. So that's what the properties are going to contain, a heading and languages. And look, you can see here, I just put prop1, that heading in here, and then like we saw there before, and as I described in the slides, I'm just mapping the array of languages that I'm getting passed into the properties here to an array of list items, right? And you can see how I'm inlining our TypeScript with our HTML, right? And using the brackets. Look at the brackets, the curly brackets allow us to do that, right? So it's worth looking at these examples to get how that works, right? How that happens, okay? And I'm passing in the properties there. So that's reusability and using the properties, right? So you can assign a single TypeScript XML element to a variable like this, right? So demo, and I can have a full kind of div, H1, H2 div, so like a full element in here with embedded elements into it. So why would you do that? Well, kind of because it's better than doing that. Well, that's what it's going to probably transpile to. But it just makes it easier to read, like, okay? And just going back to why the declarative style of doing this is just a little bit more, I guess, readable in the code. I can see what demo is here. That's demo, the constant is very constant is. Whereas here, that's far more, well, I think it's harder to interpret, right, in terms of what it does. Okay. So we've saw component iteration. We've kind of seen this already. So we can go through a component collection. So we can iterate through. So we can generate an array of similar components from a data array. So you can see it here, iteration. I think we had a look at that already when we did the map of the list items. Yeah. Here's kind of another example here. So we frameworks. So you can see here. Yeah, so list item, you can see here, I can iterate through, so my frameworks here, right? My list of frameworks here, I can map this array onto an array of component, list items here in our component, okay? So just kind of see how that works. So there you go, that map. And this is how, essentially when this is transpiled and goes out to the browser, right? There you go. So the required HTML produced by the component, right? And you can see this, by the way, if you do this, if you have a look at this in the dev tools and have a look at the HTML, the source of the component that's getting displayed in a browser, you'll be able to see this, right? So that essentially gets rendered as that in your browser, right? It gets transpiled and rendered as that. So it's pretty cool. So map is used to create a new array based on a frameworks array passed through the props object. So the frameworks array comes through the props object. We're using TypeScript here to specify what's contained in props here. It's a React functional component, and frameworks is the interface, right? We saw that before, okay, in the examples, right? So I don't have much more to go here, folks, just to finish out here. So to return, so examples of component return value. So I can return a component like this with a set of properties defined. I can also return something like this, right? Which is HTML inlined with TypeScript, right? You can see it there. So I can return, so like a bit of HTML, and then you can see my component. Look, you can see it there with the properties specified as attributes to this component, right? As an element in this HTML I'm returning. And if I do it this way, if I have a bunch of different elements, I have to essentially enclose it in an opening bracket and a closing bracket. You'll see that in the examples, in the samples, and you'll see it in the code in the labs as well. As well as that, when you're returning a component returner, if you have a functional component, you can only return one element. You can't return a bunch of elements. For instance, this will this is fine. Or no, sorry, this isn't fine, because look, I have heading one, I've got my component and I've got a paragraph, right? So adjacent JavaScript XML or TypeScript XML elements must be wrapped in an enclosing tag. So one solution could wrap all of that in a div. Okay, I could do something like that. And that's the way we used to do it in React. However, of late, what we can do here, that adds depth to your XML, essentially. So what we can do is actually just put in these special React elements. They're termed fragments, right? They have no DOM presence, so when it comes out then in the browser, you don't have kind of these unnecessary divs hanging around just to enclose React components, right? When they're rendered, you just have these these fragments, okay? I can also have React applications. It's not just one component. It's usually a combination of components, and there's a hierarchy, right? So we can embed components and components, that kind of thing. So components can have children. We can nest, right? And you can see this in the example here, in the hierarchy example here. If I go down here, you can see it here. So I have a couple of different components in here. So I'm importing web frameworks and languages. So these are two different React components. And you can see down the bottom here, there you go. I'm returning, see, web frameworks, and I'm specifying, look there, the properties of the web frameworks component, right? There they are, right? Which is the properties passed in here. And then also languages, look, see? I'm embedding another, I'm nesting another component in here too. Okay, and look, this is my fragment. You see the way I have to return one element. So I can use the fragment here, and then I can have web frameworks, then I have a paragraph, and then I have languages, and I have a paragraph. I could show you again, if I kind of open up the stories, you'll see how this renders. I go back out here, component hierarchy. If I open this, hopefully we're still running. Yeah, there it is. So there's one component rendered, and there's another component rendered. Styling isn't brilliant here, but you know, you can kind of see how it works. Okay, so there you go. Also, if I go back here, yeah, that's just graphical representation of what you just saw there. So I have the overall component. This is the component that was returned. And inside that component, I have two other components, component two, the frameworks component and the languages component. Okay, and that's kind of how we build React applications. We build components and we kind of put them all together to develop your overall single page application. And they're dynamic and they can pass information. We can kind of, you'll see how we can kind of work with them to create a fairly kind of interesting application. So look, I'm going to finish there, folks. We're out of time. Hopefully that made a bit of sense. I kind of rushed through an introduction to React. Please do the labs. So I'll be available for labs. Again, I might get back to you. Keep an eye on Slack. I have a clash during our lab time, your designated lab time. I have another lecture at that time. I only found out this week. So we're going to have to move that lab time. So just keep an eye on Slack, on the messages for when that's going to happen. Okay. But the labs are up there, and please go through them, and hopefully they will kind of help you. They will introduce you to what to React, and more importantly, as also more importantly, but importantly, they will introduce you to Vite and to Storybook and how to develop simple components using React and well, TypeScript and React. Okay, so there's a summary of what we covered today. We covered TypeScript XML. We covered a bit about components there, and a component, think of it as a function that takes a properties argument and returns a single TypeScript XML element. That's what's transpiled then into our app, right? Components also can be nested. And the Storybook tool is really useful. We can develop components in isolation, and then once we're happy with them, then move them in. Now, there's TypeScript. I've just glanced over Storybook there. Storybook is very rich. If you go onto the website, guys, you'll see Storybook here. There's the website for Storybook. It's got really good documentation. It's got showcases here, docs, and things like that, and can really talk you through exactly what's possible with Storybook. I just kind of gave you enough to get going with it, but there's far more to it if you really want to properly develop and test really good React apps. Right, folks, I'll finish up there. Has anybody any questions for me before we wrap it up? Great. Grand. Okay, so look, it was nice to meet you today. I'll see you again next week, and I'll also see you in the lab. And best of luck with the rest of the semester. If you have any questions, you can hit me on Slack, and I'll do my best to get back to you as quick as I can. All right. Thanks very much. Talk to you soon. Bye-bye.
Thank you. Bye.